Hello everyone, welcome back. My name is Rafael Scala. Thank you for watching this video. Today we will continue doing the video series about the same data intensive application book. This is the early access book that 2026 edition. So okay, maybe we can continue. And okay, maybe we can start with that data system that we have available. Actually, it's very important to know because it's everything today on the in almost all the startup, right, or web application. So there's several ways to store, to manipulate, to process the data, and you have to know the difference of them to create a data system for your company or your project that you want to tackle. Okay, so in the moment, we can see some alternatives to store the data or leave the data. We have the databases, that is a regular way to store the data, manipulate it. The caches, that is when you want to store it on the memory. The idea is obviously to have a low latency, how you want to have a fast access of the data, right? And we have the search index when you want to work with keywords, queries to filter the data. Stream processing when you want to have the real-time events in your application. The idea is to have a broadcasting of events, and you want to have the latest event when the event occur. So for that we have the stream processing. This is another way. And when you have large volume of data and there is no way to manipulate it synchronous, for that, we have the batch processing that in summary is working on asynchronous. So that's it. And the first thing that maybe to know is, okay, which alternative maybe I can have? And actually, there are several alternatives, several ways to implement, depending on the alternative that you can decide in, or depending on the goal that you want. If you have a kind of company or project, will affect the decision about how you can combine different tools about the data system, and everything should be work fine or fit in your company. You have to take note what will be the trade-off of each tool that you want to include in your data system. So it's very important to know the difference. And actually, with this book, the idea is to have um, deep deep knowledge about how to do it. Okay, so yeah, another problem that maybe we can have is how to scale. Okay, that regular scale that or maybe a challenge that you could have when you scale is the data intensive. When you have a simple processing, maybe it's in a query to get data, or maybe it's a query to manipulate the data. But the problem is that you have a large volume of data, so it's not easy to handle it. It's expensive because you have to um, uh, take the note that there are huge number of rows or huge number of files of data that you have to manipulate, right? So for that, there is some solution here that maybe we can explore here. This is the batch processing that I told you before, is an asynchronous process, right? You can design it to use parallel to work to process the data to not only just a single thread, right? And you can use multi-storage to split the data, and the idea is to be not expensive to consume the data, right? But you have to have a strategy to split them, right? And the idea is to have a highly throughput. That the idea is to support a large number of requests per second. So that is the idea, and support concurrency to maintain the data confident, that everything is be accessible, right? With when there are concurrency. So that is the idea in general. And there is another maybe problem that you can have is the computing intensive. The difference that there are a small amount of data is not compared with data intensive, but the problem could be is in the complex of the simulation. You have a critical logic that you have on your system, and maybe you are going to do financial modeling or something something scientific, I think. So the complex could be in the CPO, right? The processing of this data. So that in general, you have to know before to deep in the part of the data system. And yeah, so the main thing that maybe could know is how which system we have available to manipulate the data or get the data. Okay, we have the operation system, analytical system. We have to start with the idea of, okay, when you receive data or when you create or you manipulate or you access the data initially when you are trying to create your volume of data. So you have to imagine that in this moment we have a user here that is communicating with your server because we are working with servers applications. So this user can the possibility to write or read data, and for that we have this role. This is the first role that maybe um, involved in this design is the backend engineer. Okay, the backend engineer, the unique responsibility is to take the data that in this moment we have in the final version of the state. I mean that the data here is only the final state. The final state is not storing the 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 logs. I mean the all the event that was occur. Not in this case. It's only the final state. It's like, okay, you don't want to see how many times is updated the username. No, in this case you want to only manipulate. You only want to get the final username, right? So for that reason, this storage should be smaller because it's only storing the final version, and the user in theory should be access data fast because not need heavy queries. So that is the idea of this layer. And then when your application is growing, imagine that, okay, you are storing more data, more volume of data, and you need more knowledge about how is working your data, how is working your business or your organization. So at that moment, the system of the data started to growing. So in this case, we start to implement the part of the analytical system when the organization wants to more take more knowledge about what will be the next decision of the business. So for that reason, um, we have to hire new roles here. And the first thing is to know is that we have to a person that have the responsibility to receive all the data that was stored in this database of the operational system or the events that occur in this layer of the operational system, and want to be all them be collected in different databases that support a huge number of volume, because obviously this part of this layer, it will be more data than operational system, because it's storing like how many times you are clicking on your shopping cart, or how many times you only are creating shopping cart and you are closed, you're removing, you added more items. So that's kind of data, obviously it will be always be growing for each event that the user is doing. So for that reason, the data engineers it will handle a different infrastructure. So you have to support um, more data and have to care about the confidence or the data is not corrupted. So that's it. Taking note that in this part, operation system is continuing continuing manipulating the data, but in this part, the analytical service, the idea is not to be updated. That is in theory, because we know that all the data here is only to be analytic, right? It's to be analyzes in this case. So in the idea is that there is not input that should be updated. So the unique reason that you have to maybe update this kind of data analytical system is when there is some mistake. There is mistake in the data. There are data corrupted, and you want to fix that. But it's obviously not. That is not the idea. Okay. And okay, so the data engineer work with pipelines to transform the data and prepare the data that could be accessible. So the idea is to, if someone on the team or the business team or another developer wants data, this part, the data engineer had to be prepare the data to be accessible. So that's it. And then, well, we have another role here when the company is growing, that we need to maybe, okay, I need the data here. Okay, so for that reason, we have the analytics engineers, right? But in this case, of my personal experience, I didn't work with an analytics engineer. I know the concept, but this person is a person that is modeling the data. It's like, okay, the data engineer is working with the infrastructure, the pipelines, transform the data to not only just have the final state, in that case is like you want to prepare the data to be aggregated, the data you want to have the data prepared for each day, for example, right? So the analytic engineer, it will prepare or enrich the data to be useful or be consumed or be analyzed later. So that is a part of the analytic engineer, is model the data that was generated or was accumulated by data engineer. And data engineer will work with the data that was accumulated by the operational system that finally was created by the user, right? That is the final, the data generation, that is the data system. Okay, so the analytic engineer obviously will work with modeling the data, but who will decide which will be the model of the data? Who will decide, okay, I have the data, I can model it, but which model I have to have to create? So for that, we have another role here, is we have the business analyst and the data scientist that obviously have a different responsibility here. But in summary, is tell to analytics engineer that please tell me the data that I needed. In the case of the business analyst, is only to focus for the management role. It's like, okay, maybe the organization wants to data to analyst the how many user, I know, creates green cards or something like that. It's like very deep information that maybe the organization needs to know to take a decision about how we will be, what will be the next step for the business, but only to the business or handle it with the stakeholders. So that's the idea of business analyst. In the case of data scientist, maybe it's more creative. It's like, okay, I have this huge volume of data, and I need to maybe find some opportunity to tracking the user, or some opportunity to research a pattern to maybe take advantage to to create a future for the user, right? Take opportunity to maybe create new features for the user, only with the focus to create um, revenue, maybe in this case, right? So that is for that kind of data. We have other kind of databases that we can use. Actually, I have some example. We have Locker here. This is Microsoft BI, okay. And well, in the operational system, there are other options like right, Postgres or MySQL. Well, MySQL is duplicated at this moment. MariaDB, right? So that's it. Take note that the operational system, the database for the layer operational system is called online transaction processing, or OLTP. You have to know that the reason to have a transaction, I mean the word transaction for this kind of databases is because in the early times the database was created to create transaction about salaries, about kind of data, right? In this moment, obviously, we have for post or to store as post for store image or something like that. So, but the concept or the semantic of the word remaining at this moment. So for that reason, we have transaction, right? So this kind of data, online transaction processing, is OLTP. But for the case of analytic system, it's called OLAP, or online analytic processing. Okay, take a note of that. You have to know the concept, and you have to know that in the case of the operational system, is working with point queries, like only a single query to manipulate the data or get the data. Is not is dynamic. It's very fast. The idea to be fast and small. Okay, but in the case of the analytical system, is working with aggregate data. It's like it's trying to pull the data for some range of data or range of date. So you need the data prepare raw data that you can consume in all the time was created this database, right? So that's it. And you have to know that in the case of the operational system, is limited by the backend engineer. The idea is that the user not have the access to compose multiple queries or heavy queries, because that is no idea. Will obviously it will generate a problem of latency and maybe back pressures in your database, because there could be affect multiple users if there is a single user that is generating a heavy query. So for that reason, the query here is limited by the application or backend engineer. And in the case of the analytic system, is is freedom. Freedom of queries. I think that the thing that data science needs, or the business analytics needs, it was provided. So that's it. But you will have an intermediately maybe layer um, that affects for the user layer. That is the real-time analytics or product analytics. For example, when you want to create a project application that you need report that you have to provide the filter to get data, real-time data, but with time range of filter, time range of data, filter of time range, data, sorry, filter of date range, right? That is the reason to have this real-time analytics. It's not real time. Actually, there is obviously a time to compose it, but it's obviously it's faster than working only with that analytical system, because analytical system is working with batch processing. But in this case, the idea is to be the best of the analytical system, that maybe the data that the user needed to know some analytics of his, I don't know, his advertisement or something like that, and and that is the idea. Okay, and you have to know that obviously not everything is good for this part of the layer, because it's not equal like analytical system. Is that you have to decide between latency or throughput query. Actually, in this case, obviously the latency of this layer, the real-time analytics, it will be higher, right? Because that is the idea. But the query that you can create here will be the best one. It's like only the idea is to be of small queries, right? But with huge large of data. So that is the part of it you have to decide. Okay, you can have the best all the thing that you have on the analytical system in the operational system. That is not the idea. But okay, for that we have some databases to support this this kind of database. We have a Pinode, a Druid. So I put here some databases. So okay, for today I think that is fine. Please see my next video. I will more deep about the data warehouse. Maybe the alternative that maybe we have on cloud to compose these databases. And thank you so much. Goodbye. Take care.